Okay, everybody, what we're going to be looking at today is quadratic word problems in standard form. So basically, when you guys are looking through the word problems, you have to know what you are looking for. Alright, so we're going to kind of make a little sketch of this graph that has a negative, so I know it's going to be opening down. So I'm going to go ahead and pause the video and make a little sketch. So I've made a quick little sketch of our parabola that has a negative 5x squared plus 20x plus 60. We're going to figure out what this problem is asking us to find because the 3 points that are going to be the most important points for you to figure out on this graph is, are they asking you to find the y-intercept? Are they asking you to find the x value or the y value of the vertex? Or are they asking you to find the 0, where the graph actually hits the x-axis? Okay? And so the words are really important. It says, how many seconds after launch will the object land on the ground? So if an object is shot up into the air and then eventually it hits the ground, that means you're actually looking for the 0. Okay? So basically you're looking for the x value when the y value is 0. Like x represents the number of seconds, and that's what we're going to find for our answer. But they could also ask you, like, how high was the object launched before at 0 seconds? At the time of launch, how high was it? Well, it was at 60, looks like meters. So at the time of launch, it was at 60 meters. And they could also ask you about the vertex, like what was the highest point that it reached? That would be the y value of the vertex. Or how long did it take you to reach the highest point? That would be the x value of the vertex. So we're gonna find probably in the next few questions that sometimes it's going to ask you for the 0, which that's what's happening in this particular case. Is asking for the 0 of the function. Sometimes they might ask you for the vertex, all right, which is going to be the maximum in this particular case. And then sometimes they will ask you for the y-intercept. Okay? So how would we solve this by hand if it was asking you for the 0? So we're going to show you how to do it by hand. Basically, we're going to make the h of x equal to 0. So I'll put 0 equals negative 5 x squared plus 20x plus 60. So if I were to do this by hand, the first thing that I would actually do is I would actually just divide everything by negative 5. Just to make it easier. Just divide everything by a negative 5, which should allow me to factor it pretty easily. Shouldn't have to use the quadratic formula in this particular case. When if I divide everything by negative 5, you get 0 equals x squared. 20x divided by negative 5 is negative 4x. And then 60 divided by 5 is negative 12. Now, this allows me to factor pretty easily because I got to find two numbers that add up together to equal a negative 4, but those exact same two numbers, when multiplied together, equal negative 12. And those two numbers are going to be a 6 and a 2. Well, which one has to be negative? Well, if it says negative 4, I got to make the 6 the negative. So here we go. Here's our factors. We're going to put x minus 6 and x plus 2 equals 0. What number minus 6 equals 0? Positive 6. What number plus 2 equals 0? Negative 2. My solution set will be, that's not a very good solution set bracket, but for my solutions for this quadratic would be a negative 2 and a 6. Well, my negative 2 is going to be this 0 right here, but basically I know that at 6 seconds my y value will be at a 0. And that's what I would do if I were to solve this by hand. I could see that I could factor it and go from there. Now, if you don't know how to factor, that's when you have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And you could use this equation right here and plug in your a value is 1, your b value is negative 4, and your c value is negative 12. You could plug it into the quadratic formula, which is this right here, and you would still get the same answers, negative 2 and 6, if you just plugged it into the formula. Okay, but I'm not going to do that because that was another lesson, and you can watch that video on how to use the quadratic formula. but this is easily factorable, so I know it's going to be 6 seconds. Now, how could you check your work? Just type it into Desmos right here. And it says negative 5x squared plus 20x plus 60. So I'm going to go over here. I'm just going to put negative 5x squared plus 20x. And then plus a 60. Alright, and you can clearly see there's my 0 right there, 6, 0. If it asked you for the maximum, alright, that's way up here. Looks like it got up to, at 2 seconds, it got all the way up to 80 meters. So after 2 seconds, it hit 80. And then there's our y-intercept, 0, 60. So these are the three points that they're going to be asking you about. Either they're going to ask you a question that deals with the y-intercept, they'll ask you a question that deals with the vertex, or they will ask you a question that deals with the 0. In our particular question, it asked us about the 0. So we're going to go up here. After 6 seconds, it hit the ground. Let's go on to the next question. Marquise has 200 meters of fencing to build a rectangular garden. The garden's area in square meters as a function of the garden's width, W, is modeled by this function. What is the maximum area possible? So we're looking for the maximum area. So this time we're actually looking for the maximum of our parabola. So I'll show you guys how to do that by hand. So once again, this parabola is going to, just going to go ahead and make a little sketch here. Won't take long. This parabola, basically, you're going to start out at, this is going to have a 0, 0. It's going to go up to its highest point, known as its maximum, and then it's going to go back down and hit the x-axis again. All right, and then it just kind of continues on forever. So here, it's looking for the maximum area, which is our vertex. More specifically, it's looking for the y value of the vertex. That's what it's looking for. So how would we go about solving for our maximum? All right, there's a couple of ways to do this. We could complete the square and use our formula for completing the square and get our maximum. Or we could do another method. So we'll do both methods by hand, and you can choose whichever one that you want. So a of w equals negative w squared plus 100w. All right. So right now, one thing I'm going to do right now is I'm going to factor out a w. So I'm going to put a w, actually a negative w, makes it a little bit easier. So factor out a negative w, multiply that by a w, then I'll put minus 100. So I have 2 zeros here. Okay? Because negative w times w is negative w squared, and a negative w times a negative 100 is a positive 100w. So we have 2 zeros. One 0 will be at 0, and the other 0 will be at 100. So I know right here I'm at 100, 0, and I know I'm at a 0, 0. Now, how does this help us find our maximum? Well, here's the cool news. The maximum will always be the vertex, and the vertex is perfectly placed between your zeros. So right perfectly between your zeros. If I'm at a 0, 0 and a 100, 0, I know my x value has to be 50. Now, how is that going to help us find our maximum? Well, all I have to do is plug in a 50 into the equation. So I'm just going to go ahead and do it. Negative 50 parentheses 50 minus 100. And 50 minus 100 is negative 50. And negative 50 times negative 50 is a positive 2500, which gives me my maximum at 2500. So what did I do? In a quick little review, I factored this expression right here. I factored it, and I was able to get my 2 zeros. I plotted my 2 zeros. I realized that my maximum, my axis symmetry, will always pass through it. So what's perfectly between a 0 and a 100? A 50. Took the 50, plugged it into the expression, voila, got the 2500. So that's one way to do it. Okay? So this way, I'm going to call it the factoring method. That's one way you can factor it. Okay. The next way, we're going to actually complete the square. So what we're going to do is I am going to change my a of w just to y to make it easier. We'll put empty box plus y equals negative, and instead of w squared, I'm just going to put negative x squared plus 100x. So what I'm going to do first is I'm going to factor out a negative 1. All right. And when I factor out a negative 1, it's going to leave me with x squared minus 100x. And then what I'm going to do is I'm going to put plus an empty box right here. And so what we're going to do is we are going to complete the square. We're going to change it to vertex form. So how do I complete the square? My c value here, this is actually going to end up becoming negative c, because negative 1 times c is negative c. So what is half of 100? Half of a negative 100 is negative 50. And what is negative 50 squared? Negative 50 squared is 2500. So I'm going to put 2500 here, and I'm going to put 2500 here. And when I finish completing the square, I'm done there, so I'm going to factor this. So here's what I'm left with. 2500 plus y equals negative 1 parentheses, and this factors to x minus 50 squared. So this factors to this. So kind of quick little review of completing the square. Whenever you complete the square, whatever half that number is will always go right there, which is our negative 50. And last but not least, all I'm going to do to both sides, it's negative 2 on 2500, is I'm going to add 2500 to this side, and I'm going to add 2500 to this side. And so here's my final answer. I'll change everything back to a of w. A of w equals negative 1, open parentheses, x minus 50 squared plus 2500. Hands getting a little tired here. There's our answer in vertex form. And our vertex is going to be at 50, 2500. That's going to be our vertex. There's your x value, there's your y value. Okay? So, by hand, how would I do it? I think it's a little bit easier this way, just to factor it, find your zeros, find that halfway point perfectly right there in the middle, plug it in, get your maximum. But you could also change it to vertex form and find your vertex. But when you're done, the main thing you want to do is I would change it to x squared and put minus x squared instead of minus w squared, because Desmos graphs in terms of x, plus 100x. Okay, that's it. Yep, there we go. Go to Desmos. You're going to have to zoom out quite a bit. I'm just letting you know, you have to zoom out way far out, because if you're going to get all the way up to 2500, it's a long ways. So there we go. There's your vertex, 50, 2500. And so on this one, it takes basically 50 meters of width to produce the maximum area of 2500. So what's the maximum area possible? 2500. If it said what was the width required to build the maximum area, then the answer would be 50. All right, we got one more. Hey, look at this one. This one we've already done, but it asks a different question. It says, what is the height of the object at the time of launch? Well, we've actually already done this problem, okay? But this time it's not asking for the maximum. It's saying, hey, what's the height when the object was launched? Let's just go back. Let's take a look. All right. There we go. At the time of launch, right here, it was at 60 meters. So remember we said these are the three questions they could ask you about. They could ask you about the maximum, the y-intercept, or the zero. So this one's going to be really easy. All right. Just says, oops, hold on. What is the height of the object at the time of launch? We're going to say 60, because that's your That's your y-intercept. So I'm just going to write a 6 and 0 at the time of launch. All right, type in 60. You're done. All right, so make one and quick review. Make sure you know that it's either asking about the y-intercept, the vertex, or the 0. Good luck when you're answering these questions. Make sure you read the question carefully before you decide to type in an answer.